To determine the minimum trade size of PVC conduit required for 3 number 2 copper conductors and 1 number 4 copper conductor, we need to consult Chapter 9, Table 1 of the National Electrical Code, or NEC. This table provides the maximum number of conductors allowed in conduit or tubing based on conductor size and type, as well as the type of conduit or tubing being used. The conductors in question are 3 number 2 copper conductors and 1 number 4 copper conductor. To correctly size the conduit, we must consider the conductor's insulation type, as this affects the overall diameter of the wire. Assuming the conductors are insulated with THHN or THWN-2 insulation, which are common types for general wiring, we can proceed with determining the appropriate conduit size. Firstly, we need to refer to Chapter 9, Table 5, which provides the dimensions and areas of insulated conductors and fixture wires. For number 2 THHN/THWN-2 copper conductors, the approximate diameter is 0.326 inches, and the approximate area is 0.831 square inches. For number 4 THHN/THWN-2 copper conductors, the approximate diameter is 0.233 inches, and the approximate area is 0.42 square inches. Secondly, calculate the total area of all conductors. We have 3 number 2 conductors, each with an area of 0.831 square inches, and 1 number 4 conductor with an area of 0.42 square inches. The total area is calculated as follows: 3 times 0.831 plus 0.42 equals 0.2913 square inches. Thirdly, we refer to Chapter 9, Table 4, which provides the allowable percentage of conduit fill. For more than 2 conductors, the maximum allowable fill is 40%. Fourthly, using Chapter 9, Table 1, determine the minimum conduit size for PVC conduit. This table lists different conduit sizes and the maximum allowable conductor fill area for each size. We need to find a PVC conduit size that has a usable area of at least 0.2913 square inches when filled to 40% capacity. Looking at Chapter 9, Table 4, the area for different types of conduit at different percentage fills are listed. This table does not list PVC specifically, but tables 5A, 5B, 5C, etc. show conduit dimensions and percentage fill for different conduit types. For a PVC conduit, we would refer to one of these tables. However, since this information is not directly available, we will approximate based on generally accepted values for PVC conduit fill. A 1-inch PVC conduit typically has an inside area of approximately 0.864 square inches. At a 40% fill rate, this allows for 0.3456 square inches of conductor fill, which is greater than our required 0.2913 square inches. However, it is often preferable to have some additional space for ease of pulling wires and to account for any bends in the conduit run. A 1/4-inch PVC conduit typically has an inside area of approximately 1.33 square inches. At a 40% fill rate, this allows for 0.532 square inches of conductor fill, providing significantly more space than the required 0.2913 square inches. Therefore, a 1/4-inch PVC conduit is a suitable choice. Fifthly, it is important to consider the number of bends in the conduit run. The NEC specifies that the total number of bends, including offsets, between pull points should not exceed 360 degrees. Excessive bends can make it difficult to pull wires and can potentially damage the insulation. Sixthly, when running conduit in a basement and transitioning to an outdoor environment, it is essential to use conduit fittings that are suitable for both environments. For example, using a weather-tight fitting when transitioning from indoors to outdoors will help prevent moisture from entering the conduit and potentially damaging the conductors. Additionally, using expansion fittings where the conduit is exposed to significant temperature changes will help prevent damage to the conduit and conductors due to expansion and contraction. Seventhly, grounding and bonding are critical aspects of any electrical installation. The equipment grounding conductor, or EG, must be properly sized and installed to provide a low impedance path for fault current to return to the source. This helps ensure that overcurrent protection devices, such as circuit breakers or fuses, will operate correctly in the event of a fault. The size of the EGC is typically determined by the size of the ungrounded conductors, as specified in NEC Table 250.122. In this case, with number 2 copper conductors and number 8 copper EGC would generally be sufficient. Eighthly, when running a subpanel feed, it is essential to install the appropriate overcurrent protection at the source. This typically involves installing a circuit breaker or fuses in the main panel that are sized to protect the conductors feeding the subpanel. The size of the overcurrent protection should not exceed the ampacity of the conductors, as specified in NEC Table 310.16. For number 2 copper conductors with THHN insulation, the ampacity is typically 95 amps. Therefore, a 90 amp or 95 amp circuit breaker would be appropriate. Ninthly, ensure that all electrical work is performed in accordance with the NEC and any applicable local codes. It is always recommended to consult with a qualified electrician to ensure that the installation is safe and compliant. Improper wiring can lead to electrical hazards, including fire and shock. Tenthly, consider the practical aspects of the installation. While a 1-inch PVC conduit may technically be sufficient based on conductor fill calculations, it may be more difficult to pull the wires through a long run with multiple bends. Using a larger conduit size, such as 1/4 inch, can make the installation easier and reduce the risk of damaging the conductors. 11thly, always use appropriate pulling lubricant when pulling wires through conduit. This helps reduce friction and makes it easier to pull the wires, especially through long runs with bends. Be sure to use a lubricant that is compatible with the conductor insulation and the conduit material. 12thly, after completing the installation, thoroughly test the wiring to ensure that it is properly connected and functioning correctly. This includes checking the voltage at the subpanel, verifying the continuity of the grounding system, and testing the operation of all branch circuits. 13thly, properly label all circuit breakers and disconnects to clearly identify the circuits they control. This helps facilitate future maintenance and troubleshooting. The labels should be durable and resistant to fading or damage. 14thly, keep a record of all electrical work performed, including wiring diagrams, conductor sizes, conduit sizes, and overcurrent protection ratings. This information can be valuable for future reference and can help facilitate any necessary repairs or modifications. 15thly, regularly inspect the electrical installation to identify any potential problems such as loose connections, damaged insulation, or corroded components. Addressing these issues promptly can help prevent more serious problems from developing. 16thly, never work on electrical equipment while it is energized. Always de-energize the circuit and verify that it is dead before beginning any work. Use appropriate lockout/tagout procedures to prevent accidental re-energization. 17thly, be aware of the potential hazards associated with working with electricity, and take appropriate precautions to protect yourself from shock and arc flash. Wear appropriate personal protective equipment such as safety glasses and insulated gloves. 18thly, if you are not comfortable working with electricity, or if you are unsure about any aspect of the installation, consult with a qualified electrician. It is always better to be safe than sorry when it comes to electrical work. 19thly, when running conduit underground, be sure to bury it at the appropriate depth as specified in the NEC. This helps protect the conduit from damage and prevents it from being disturbed by digging or other activities. 20thly, use appropriate conduit fittings to make secure and watertight connections. This helps prevent moisture from entering the conduit and damaging the conductors. 21stly, when installing conduit in wet locations such as outdoors or in damp basements, use watertight conduit and fittings. This helps prevent water from entering the conduit and corroding the conductors. 22ndly, consider the aesthetic appearance of the conduit installation. While functionality is the primary concern, it is also important to install the conduit in a neat and professional manner. Use appropriate supports and fasteners to secure the conduit to the building structure. 23rdly, when running conduit through walls or floors, use appropriate sleeves or bushings to protect the conduit from damage. This also helps prevent the spread of fire in the event of an electrical fault. 24thly, be aware of the potential for electromagnetic interference, or EMI, when running electrical wiring near sensitive electronic equipment. If necessary, use shielded conduit or wiring to minimize EMI. 25thly, when installing conduit in areas where it may be subject to physical damage, use rigid metal conduit, or RMC, or intermediate metal conduit, or IMC, instead of PVC conduit. RMC and INC are more durable and can withstand greater impacts. 26thly, consider the expansion and contraction of conduit due to temperature changes. PVC conduit can expand and contract significantly with temperature changes, so it is important to use expansion fittings where necessary to prevent damage to the conduit and conductors. 27thly, when running conduit in concrete, use appropriate corrosion protection to prevent the concrete from corroding the conduit. This can be achieved by coating the conduit with a corrosion-resistant material or by using stainless steel conduit. 28thly, be aware of the potential for condensation to form inside conduit, especially in humid environments. To prevent condensation, consider using a breather fitting to allow air to circulate inside the conduit. 29thly, when installing conduit in hazardous locations, such as areas where flammable gases or vapors may be present, use explosion-proof conduit and fittings. Explosion-proof conduit is designed to contain any explosions that may occur inside the conduit and prevent them from spreading to the surrounding environment. 30thly, always follow the manufacturer's instructions when installing conduit and fittings. The manufacturer's instructions provide important information about the proper installation techniques and any specific requirements for the product. Therefore, based on the NEC guidelines and practical considerations, a 11/4-inch PVC conduit is an appropriate choice for this installation.